Hello everyone. In this video, I want to talk about a blog that I wrote about probably about a week ago, something like that. October 25th. There you go. October 25th, 2016. So a little over a week ago, and it's received a decent amount of likes considering the connections that I have. I got 18 likes and 2 comments, which one of them is mine to share. Now, basically, I'm talking about why I don't spend too much energy into learning Sitecore. And the reason why I wanted to write a blog about this was because I get a lot of demand for Sitecore here in Melbourne. Now, I don't know what the rest of the world's like, but Sitecore seems to be the one thing that every recruiter calls me about. So I thought I was getting a little tired of it, and I was kind of I was like, I had to keep explaining to these recruiters all the time. Well, I know Sitecore, I've used it, but I don't focus all my time on it. And they kind of think from that you just, you're not the right candidate, or you're not smart, or that you just, for whatever reason that they put you in the, oh, you're not good enough bucket. And the same as anyone who's looking for a specialist in Sitecore too. They're quick to jump on, you haven't done any experience before in Sitecore, you mustn't be a good programmer. And it's not that at all. And I understand that people want, companies want people who instantly jump on the Sitecore bandwagon because it's a valuable asset to them. But I think the one thing, and which I explain here in my blog, is that people are missing is that they keep hiring people who, they're good at one product and they're good at one tool, but they're not really programmers. And I actually spoke to someone the other day about this, and he goes, "Well, what do you mean they're not really programmers? They're writing code, aren't they?" And I said, "Yeah, there's a difference between a coder and a difference between a programmer. And in my mind, a coder is somebody who understands a tool very well, understands a language very well, and can write code. They can just churn out anything and get something done, right? And that's important in a lot of ways for some companies, like especially if you're, in a smaller market and you need to churn out code fast, and you're not having to worry so much about performance and throughput and security and all these other aspects that a lot of other industries have to worry about. Great, that's fine. You get a coder in, he'll code you up something, and it'll look okay, I guess. And it'll work somewhat okay, and that's it. That's fine. That's cool. And I find that to be the case with Sitecore. They just want to get people in who can quickly drill out some code and make things look presentable in their CMS website. But when I say programmer, what I'm really getting at is somebody who doesn't just write code, because obviously writing code is part of a programmer's job, but the more important aspect is that they go about thinking about what they're going to do. So, for example, you might need to build a shopping cart application, right? Now, somebody who's a coder might just go, okay, I'm gonna store an order, and the order's going to be linked to a person. They'll store it in a table, and and they'll just do a quick little write up, and and it might work for small applications that only require maybe a couple of line items or things like that. But a programmer will think more, how many people is it going to affect? What's the performance matrix? What security do we need? Do we have to disable shopping accounts for different users? What kind of credit card validation we're going to use? What payment gateway we're going to need to apply to the shopping cart? We'll think more beyond the spectrum, and then when we actually have to process it, then we think about, well, how are we going to pass around the payment information? Somebody who's a coder would just pass the credit card information straight through. That's a big security risk. A programmer knows differently. They think, okay, we can't pass around credit card numbers because it's a security risk, so what do we do? Oh, well, what we'll do is we'll pass the information on to another environment which has the ability to store credit card numbers, and they'll give us a token, and then we'll pass that token down to our payment provider when we're ready to pay, and so on and so forth. This is what we think. This is what programmers do. And then even when you're looking at code, right, a coder will generally copy paste what they understand from the internet, and for the most part, it will work. Well, a program doesn't do that. They may take code from the internet, but they'll always sit down and logically reason as to why that code works, and they'll try and learn from it. They'll try and adapt it, and so on and so forth. The other thing that a programmer does that a coder doesn't do is they apply design patterns and theory to what they do. So, for example, if I look up things like, software design patterns, right? Now, this stuff here that I'm about to show you, I don't know if this is the best link. So there's different type of patterns here, like an abstract factory pattern, and it'll give you an example of what that is. Now, a coder probably wouldn't be able to understand this straight away in order to go, okay, I'm going to build my code in a particular way so that it's what's considered robust. And robust means basically that it's not going to break. You've done it in such a way that it's easy to understand, it's reusable. It's not a headache for new developers to come in and try and change it if they need to change it, that kind of stuff. And this is just one pattern. This is just one class diagram that indicates what you would do if you did an abstract factory pattern. And then it goes through all the concepts of what it is and what it does and all this kind of stuff. And that's just one of them. And then there's like 100 more. There's builders, there's lazy initialization, prototyping. Singleton is a quite common one that we use these days. And there's bridges, there's decorators, there's facades, there's flyweights, proxy pattern. We forward on a call to something else using a proxy. Chain of responsibility, the command pattern where we basically issue certain chunk of code in a command, we can undo it. The iterator, the iterators having the ability to iterate over a certain amount of logic, certain amount of times. All these different things, right? A programmer will spend his time going through these, and he won't know all of them, obviously, but he'll understand the logic. The logic is the key word behind a lot of these patterns, and these patterns can be applied to almost any programming language. So it can be C#, it can be Java, it could be even Swift, Objective C, C++, even C++. They're designed to be, cross language essentially. Like you don't see in here any examples for. So if I pick one, say, let's go. Where's the observer pattern? There's the observer pattern. So the observer pattern is like you have a subject, and then you have a person observe that subject, or the observer has a subject, and then you've got a bunch of observers that watch the observee, that kind of thing. Now in this one, they do have a Java example, and then they also have that's also Java. And there's a Python example, so you can see, they're basically what they're doing is they're implementing how things can work in different languages. It's not specific to a certain language. Now, a coder doesn't care about this, generally. A coder they might know a little bit just from learning from programmers, but a coder will go, that's Java, I don't care what this does. I need to write it in C#, I don't even know what this means, right? And they'll go on, they'll solve a problem in a really convoluted and complicated way, to which they've overcomplicated the system, and they've also probably created a huge chance of having bugs in the future when somebody changes it. Basically, a programmer doesn't do that. A programmer will take all those things into consideration and code with that in mind. The other thing that programmers are pretty aware of, and if you're not, you should know about these, is the solid principles. So there's this concept of solid, and basically there's 5 different principles that you need to know. The main one being the single responsibility principle, and the Liskov substitution principle, and the open-close principle. Those 3 are probably the main 3. Interface segregation is kind of important, and dependency inversion is also something that in some systems they prefer you to inject dependencies into other objects. So I'll just briefly go through a few of them. Single responsibility basically means that each object or class or, model of work, we'll say, generally known as a class or a module in most languages, is responsible for doing one job. So just say you got a car, right? A car, like, you're not going to put in code to ride a bike in a car model, right? Because a bike is a different thing altogether. So you leave that out of the car class. You would only put in things to do with the car, like drive, change tire, all that kind of stuff. The color, what the color of the car is, how many doors, how many windows, how many mirrors, change brakes, apply brakes, start it up, that kind of stuff, right, would all go into the one class. But not only is it specific to a class, each method or function, right, is also responsible for one task and one task only. So, for example, you wouldn't have a function that both turns on the car and makes it go, pushes the accelerator. You would have one function that turns on the car, and then you would have another function that makes it go. So you would have to make two calls, one to start it up, as you would in real life. You start up the car, and then you go, right? You reverse out and go, right? That's kind of what this single responsibility principle is getting at. It's basically saying one class should have one reason to change only, and that's the quote here right here. A class should only have one reason to change, and that's because it's only doing one thing. And it's the same with methods. I don't know if it indicates here methods. It just seems to say classes, but even with methods, I also recommend the same thing. A method, for the most part, does one thing and one thing only. So that's that one. Now, the open-close principle basically is to do with you can't modify how the functionality of a method or a class works, except if you're applying a dependency, such as, for example, a car relies on an engine. You can replace the engine, but you can't change how the car works. You can only add a new engine, right? So it's open for extension. It's open to add a bigger engine, but you can't modify how the car works in order to make that engine work, if that makes any sense. So basically, the engine has to be compatible with the car, so it can extend the behavior of the car by making it faster, so to speak. But you can't change how the car connects to the engine. Like, you can't change the leads, you can't change the wires, you can't change, all that stuff, right? That's what this principle is, and they're saying in code that, if I'm to apply a new engine, it shouldn't affect the code that already exists inside the car. Or inside the car class, it should operate the same. So when I go turn on, I shouldn't have to write any new code that starts the engine. I should be able to just say engine.start instead of, and that's kind of how you think about it, The engine is part of the car. When you replace the engine, then you're still going to start the engine, aren't you? And so that's what this open and closed principle is. So it's open for extension, i.e. putting in a new engine, but it's closed for modification, i.e. I can't change how the car works in order to start this engine. The engine has to be compatible, essentially. And generally how we do that is we pass it through either through inheritance or through interfaces. Or what do they call it? Abstract methods and things like that. So that's kind of what that's saying. List code substitution principle is more about including subtypes in the place of a parent type. So, for example, say you have a person and you have a class that goes register person for driver's license, right? But you pass in, just say the person has normal adult and employee or something, right? So basically, it's the behavior of registering a person or an employee could change based on whether it's an employee or not, but the code that's being used to apply those changes are kept within the type itself, not within what's calling or what's asking for the type, if that makes any sense. So, for example, the registration system wants an employee, right? So the employee knows how to register itself. So it has different set of code that says, I'm going to register myself. That's cool. I know how to do that. Whereas an normal adult would say, look, I don't know how to do it. So then, in this case, it might, the system might say, okay, well then we'll get someone to do it for you. It's a different behavior, but it's based on the different types. The different types have ways of handling its own registration, so to speak. But it's all passed in through the same gap. So a person will have a please register on it, or register, right? And both an adult and an employee can have a register method, and that holds the implementation. So that's the substitute principle. You can substitute any subclass for a parent class, essentially. If you know object-oriented programming, you'll know what I mean by that. Interface segregation. This is more to do with sometimes you'll run into situations where a class needs to do more than one thing. And so instead of having just one interface that does everything that class does, right, because it may have two different types of behavior, what you do is you break it up into, two or more interfaces, and then you implement each one on that object. So, for example, say we have, again, we'll go with the car, right? And one of them could be an I switch, right? So, and an I switch has turn on, turn off, right? And then on top of that, we've got, I don't know, I replaceable, okay? Which means that we're going to replace a part. And on that side of that, it might say something like replace tyre, right? So on a car, we have the ability to replace tyres, and we have the ability also to turn on and off. So the I turn on or off would be applied to the car, and so would the I replaceable. But because they're two different responsibilities, and that the I turn offable, or I switch, or whatever we call it, can be applied to something else, not just a car, it's segregated away. And that's kind of why it's called interface segregation, because you're separating two different responsibilities away and splitting the interface out. So you have all the responsibilities are separated, essentially. But see, these kinds of concepts are the things that are important, rather than there's not one line of code that I've seen here at this point. And this is why I say we're programmers. We are planned to think, and we think like this. We apply different principles to different problems. And then this one, obviously, dependency inversion. Essentially, what it means is that you're decoupling, what we call decoupling, dependencies from one to the other. So, for example, as I just said, there's an engine inside of a car, right? And the engine is like a car depends on an engine, but how the engine is built is different. So you've got a V8 engine, and then you've got a 4-cylinder engine, right? So the 4-cylinder engine will have a turn on feature, same as the V8 will, right? So that doesn't change. But the other parts of like how many cylinders, one's 4 cylinders, one's 8 cylinders, what type of cylinder arrangement is it? One's V-shaped, one's straight line. That makes the engine different from each other. But a car just says, I want an engine. So you give it an engine, right? Because at the end of the day, all it needs to know is how to turn it on. It doesn't care how the engine turns on. It just cares that if I plug myself into the engine and I ask it to turn itself on, it turns on. And starts up the fan and pumps petrol through it and so on and so forth. And, when I'm ready to accelerate, it's going to push the car along, That's essentially what dependency inversion is. It's taking away the dependencies of what an object might depend on, and decoupling it. So you can basically do things such as unit testing, which is one of the important things. So you can fake out your own engine to test out certain parts of the car to make sure that the other parts of the car is working, rather than trying to use a real engine, which would make the car take off when you don't necessarily want it to take off. You just want to test it while it's in stationary, that kind of thing. So essentially that's what dependency inversion principle is that. There's some fandangled words. You can go through this if you want. It says here, high-level modules should not depend on low-level modules. Both should depend on abstractions. So again, essentially what it's saying is, a car should depend on some kind of engine abstraction and not an actual physical engine. So something that's going to behave like an engine, but not necessarily is an engine. But when I put in a real engine, it will behave the same as the fake one. That's essentially what it's saying there. And it says abstraction should not depend on details. Details should depend on abstractions. So again, we can build a different car with different types of engines and different types of, wheels and all this other stuff. We don't depend on what the types are. We just depend on the abstractions of the types. And we know it's a wheel. And the wheel's got to fit on the car, I think that's the best way I can explain it without being too technical and using too many fandangled words. But that there, solid principles, very important to understand, as well as your object-oriented principles, which I'm not going to go through in this video because it's going to take way too long. But if you look up OOP principles, I'm sure you'll find a very good example of. There we go, object-oriented programming. Oops, what's this? Remember later. Yeah, install. So here, I think I've actually clicked on this before, but see, this would be quite important to go through as a programmer, not necessarily a coder. Though coders would have to deal in situations with inheritance over time. A coder generally will learn this information anyway, but probably not to the same extent as a programmer, because a programmer is more likely to understand the logic of why it does what it does, as opposed to here's some more design pattern ideas, some more patterns here. But responsibility with data-driven design. So there's all these different kinds and there's the solid principles again. I've already gone through some of this stuff. But basically, it's very important for a programmer to understand these concepts. And this is just for programming. This is not dealing with things such as the cloud. Oh, come on, Java. See, a tool driving me nuts. No, I need it, so I'm going to leave it. The other thing, if you're into cloud infrastructure, cloud design patterns is another one that's of importance to look up. We've got AWS design, cloud design patterns. So you've got a whole bunch of them here. Scale out pattern, scale up pattern, snapshot pattern, multi-server pattern, all these different kinds of web-related, network-related patterns that you can apply to your code. Again, I think if you click on one of these, if I go scale out pattern, for example, again, it's all diagrammatic. There's not really, so if you read through this, it's probably more just like theoretical, but again, no code, so coders might get shied away from looking at something like this. Also, programmers and even architects will look at this stuff and find that it's important. But the main thing here, EC2, EC2. What they're talking about here is the ability to scale out, which is basically replicating the same application multiple times and having it load balance. So what a load balancer is, it literally comes in and goes, oh, I've got a request, which instance do I want to go to? I'll go to this one. And the next one will come in and go, I want to go to this one. And it'll evenly distribute the load across all these different boxes, right? That's essentially what this is talking about in small detail. But even all this stuff, this is all programmer stuff, not necessarily coder stuff, right? Code stuff would be more like to go, if I go Swift 3, where's the documentation for Swift? Swift Apple. This might be it. Maybe not. Oh, where's the? So they'd be more likely to look at stuff like this and understand the actual code and what it does, or what have we got developed? API. They'll look at an API reference. No, maybe not the API reference. Well, yeah, essentially they can come in here, and that you can see like, oh, I want to work in media. Okay, what does the AV Foundation library give me? Oh, it gives me assets. It gives me an asset reader. But down here somewhere, audio. Where's the video one? Is this the one that does AV player? AV player, AV player. AV player layer. This must be one that says AV player. So there you go, AV player, right? And this is what's used to make videos, right? Inside of iOS. And they'll come in here, they'll read all this stuff, they'll try and understand what does all this mean. You know, they've got some methods, it'll explain how these methods work. But it doesn't tell them anything. And look, even here you can work out, oh yeah, play, pause, rate. You know, if you click on one of these, it'll tell you how to implement it. In case this, it doesn't tell you much at all, it just says play. But it says calling this method is the same as calling rate and setting it to 0 to 1. But yeah. But basically all this stuff, this is language information. This is about, but that's not exactly 100% what I was looking for. That's basically what's referred to as an API library or a reference environment. But there should be a Swift language reference. Maybe it's that. Maybe this one. Here we go. Language guide. So you'll come here and programmers will look, oh, that's how you write a constant, that's how you write a variable. Oh, okay, so we have tuples, cool, that's nice, that's how you declare a tuple. You know, and then they might say, oh, how do I do an array? And they might look down and go, collection types. And they go, oh yeah, here's the array. Like they understand what an array is, but they don't understand 100% maybe how it works under the hood. And they go, okay, how do I do an array? Okay, that's how I write an array, cool. And then they'll just start writing code. Oh yeah, that's how I add a value, right? Gotcha, append. You know, and they'll become specialists at this. Like this is the area that they focus on the most. You know, this kind of stuff. And then there is a section here on inheritance, but it's more about how to write inheritance rather than explaining what inheritance is, what's polymorphism, all that kind of stuff. Like I don't see polymorphism here unless they've got subclassing, overriding. So they do cover a lot of the object-oriented principles in this documentation. Override, overriding, properties. So you know, properties in Swift. That's interesting. But see, there's no polymorphism. They don't talk about interfaces in any way. Though I think, if I remember, protocols are your interface jobs. So it's when you can say this has more than one behavior. So this is your interface segregation. That's what this is here. So the first protocol, another protocol, they do two different things, but combined they do something more complex. You know. But basically, this is what coders do. They're not programmers. So I hope this makes more sense. I recommend you definitely go and read my article. That'd be great. I go through in more detail about what I consider programmers and what we do over what I consider just people who work in Sitecore do. Like at the end of the day, I write here, basically I put myself into a position that I'm hybrid. I can go anywhere at any time and nearly do anything with the right time allocated. And to me, that will always be more valuable and more flexible than putting myself into one skill bucket, such as most programmers do. And I say here programmers, I really should say coders, do with Cyclops. But I didn't want to insult people, I just put programmers. But yeah, so I guess that's the gist of this video. I just wanted to give people some insight what I meant in terms of programmers versus coders. There is a difference to me. I know a lot of people will say there's no difference. To me, there is. It's very important that your foundations of programming is there, as opposed to just learning a language. Learning a language is great, right? I'd probably recommend as a little kid, if you, or not a little kid, but like a 13-year-old just starting out, maybe go and learn a language. I think that's important over learning programming principles. But at the end of the day, when you want to get serious in this, I think you need to put the time into understanding all the programming principles needed to develop good software. Because at the end of the day, anyone can write code, but not everybody can write good software. And as I said in here, what separates us from the pack is the ability for us to reason with logic and apply the right patterns to the right problem. And that's what I feel like I've done to this point in my career, but I'm not 100% perfect. But we continue to evolve, and that's what matters. Anyway, I'm rambling now, so I'm going to catch you all later, and please go and have a read of my article. I'll really appreciate it, and I'll see you guys next time. Thank you.